Okay. All right. So last time, I think we just kind of have our interface going. I just did a kind of a crash course Android dealy flippy thing last time. So we didn't actually implement any of our registers in here for us, right? So that was all part of the assignment. Okay. So let's so we're going to kind of bring this up to speed, and then we're going to kind of do a couple little breakout groups in here, write some logic, and incorporate it into the project. So it's a little bit more interactive. We'll see what happens with that. Okay, so it's here. So now we're trying to emulate the 8086 processor, right? So we're trying to do the dumbed down Intel architecture from 1979 or something like that. I think the processor was actually made in 77 or 6 or something, but whatever. Okay. Well, I think the manual's from 79, but I think the first version of the architecture was 77. Okay. All right, so here was kind of our Java implementation. So we talked about initially having 4 registers, but each register divided into the halves. So we're going to have 16-bit registers, AX, BX, CX, DX. So how did we go about creating those registers? How did we implement them in your assignments? How is AX represented in your Android application?
I did a byte array for A, and then AH is byte space 0, AL is byte 1, and then AX is essentially not really a thing, but you can call get AX and it combines the two, and then gives you AX.
Okay, so you effectively did a bunch of 8-bit registers.
Yeah.
With a getter for combining them into a 16-bit register.
Yeah.
Gotcha. All right. So that's not a horrible idea. I mean, so you don't directly have access to something called AX, but you can grab AX, which is AH and AL smashed together.
Yep.
Fair enough. Okay. I think it's actually a pretty decent way. Anybody do something substantially different?
I made register objects.
Okay. Well, tell me about your register objects.
Like they each have a name, a label, a text view that's associated with them, and a value. And then you just essentially fill in the information for those, assign them their text view values to the text views that you want to show the value for, and then when you do the logic, you fill those in.
Well, right, but so you still have to represent AX as a 16-bit register. So underneath the hood, so I get that you have this register object that knows how to display itself on the screen and that kind of stuff. So I get that. But in terms of the underlying data structure for AX, how did you represent it? Was it a 16 bucket or integer array? Was it, so like for instance, he mentioned he created for AX, for example, he created 2 8-bucket byte arrays. One he named AH, one he named AL. Actually, I think he just named it A, with bucket 0 being AH and bucket 1 being AL, whatever. Okay, and then he had a function that said, if you want AX, you want the whole 16 bits, I'll go ahead and glue these guys together for you. Here. So how did you implement your version of AX or BX, CX, those guys, under the hood?
Originally, I just did a hash map.
Okay, and how did your hash map work for that? Like, why a hash map?
Because that was how I did it was when basically it parsed out the instruction and took the value that you were trying to put in.
But we're not even talking about the instruction yet. I'm just talking about the register.
Oh.
Just the register.
Oh, in that instance, it was just assigning the label to the value.
All right, so you didn't really give any structure to it, limiting it to 16 bits or 8 bits or anything like that. Okay. Anybody else do anything?
Still technically in progress.
All right, anybody else do anything?
I have a list of 4 different strings. It's 1 character each. It's a hex. It's stored as the hex value.
Okay, so you kind of mapped You kind of looked at what we did. Well, I think we looked at this, the 8086 emulator,
Yeah.
and how it represents AX and BX and those guys, and has the two bucket things for hex. Yeah, I think
it's one bucket with 4 hex characters in there, and when I send something to like AH, I just put it in the first 2.
Yep.
It just built in the first 2.
Gotcha. So your AX, so was that, it was an array of chars, or is it a string?
String.
Okay, so AX was a string that you artificially limited to 4 characters just because
Yeah.
you were dealing with character at bucket 0, character at bucket 1. So what, you rebuilt the string every single time you had to change it?
Yeah.
Okay, or you used like a string builder or something like that to make it convenient, but
It's a list of strings.
well, that's for all your registers. So you had a list of strings for your collection of registers?
No. Each string is a list of length.
A list of length 1 strings.
Yes.
So it could have just been a list of chars. Except the char is a primitive type, and you had a okay. I got it. All right. So AX was a list, or you could have even done it as an array of strings, where you said that each string is 1 bucket big.
Yeah.
Okay, fair enough. So that kind of approaches it similar to what this EMU 8086 does. Yeah, I kind of like that. Anybody else do anything different? Anybody do something better than Tim? Yours sucks.
I know it does. I was gone most of the week. I didn't have enough time.
Where were you?
Indiana.
It doesn't take that long to do this.
Yeah, even Haxton did it. And he's been trying to farm legendaries.
I know. I killed 5 bosses in a row. I used 3 coins, and I didn't get a single piece of gear. That's 8 chances. I didn't get a single piece.
See, I find that funny.
Life sucks.
Yeah. Okay, so let's do this. We're going to start off. I just want to kill this right now. Well, let's leave this open, actually, because we might want to reference some of the stuff in here. Okay, so if I go ahead and just run this real quick, just so we can model his. So he implemented his high and low, kind of like these guys over here, where AX, and for right now, we're only pretending we have 4 registers. We're going to expand this, but we really want to try to mimic the early Intel architecture in an Android application or Java app. It doesn't really matter. Just Android makes it a little bit more interesting to have visuals. But we're starting off with just a small subset of the registers, AX, BX, CX, DX. And since this guy represents them in hex, because of footprint, right? Kind of nice small footprint, we need to be able to do the same thing in ours. Just because we're trying to create an Android version of this app, I think that approach is a pretty decent approach. That doesn't mean that your solution was a crap solution. It was way better than Tim's. Well, this other Tim was a pretty good solution, so these are kind of even. What kind of salad did you get? What kind of salad was it?
That's gone already? Oh my goodness.
Oh, you just slap something together?
Yeah.
All right.
Bring him one next time you can.
I touched him.
He asked me. Yeah, he asked me. Okay, so let's start off by giving ourselves a couple of tools for converting values. All right, so we're going to be reading stuff in. I mean, chances are, as users, we're going to be given our value as decimal. But we should be able to give our values as binary or hex if we want. We should be able to move into AX a hex value or move into AX a binary value. So we need to have the ability to convert between, at least those 3, if not also octal. So you might as well do it for octal as well. So we need a tool that's going to convert from decimal into hex, and into binary and all sorts of stuff like that.
They have it built in.
They do with what integer.parse end.
And then they also have you can do the string version.
Yeah. So one possible issue we're going to have is I think we looked at this last time. Doesn't it give you more bits than? There's a way to limit the bits.
Well, I never had that issue when you
Yeah,
use.
you can You can do it in a cheating way, but yes.
Okay.
I used
Well, so let's go ahead and let's just build ourselves a little class with some static methods in it for converting that we can throw a value into it and it'll shoot a value back out just so we have a tool available to us. So I'll go ahead and just right click here. We'll create a new Java class and let's call this guy converter. Okay, and we're going to fill this guy up with a bunch of static methods. So one thing we might want to do is we might want to have decimal to hex. That's kind of a requirement for your guy. So it's going to take in an integer as a parameter, for example, and spit out a string representation of it in hex. Okay, so we'll make this guy static. He's going to return a string decimal to hex. It's going to take in an int val. Let's do int dc like that. And so what is it? Integer dot parse int. And this guy takes in, actually, is it?
Yep, that one. You can choose the base with the radius.
So I'm going to need to do this, build a string out of my decimal, and then do that, right? And that should give me the hex version of that decimal, the string representation of my decimal value.
No,
Are you gonna return?
that returns an integer.
The parse?
Well, I haven't returned anything yet.
Well,
Well, no, that won't return an integer. It's going to return a string. Integer.parseInt has to, oh, no, this comes out with, this says this is a decimal value and I want the base 16. Okay, this doesn't do the conversion for me. This says if I pass it a hexadecimal string, it'll give me the decimal equivalent, the integer equivalent of that guy.
Yep.
All right, so what's the converter that's built in that will allow me to take a decimal integer and convert it to,
integer
Two hex
value of integer
The
dot
same
two
hex
hex
string.
string. Instead of passing value of, yeah, just integer dot two hex string.
okay, we have two binary string and we have
2 octets.
two oct. Okay, perfect. That's exactly what we need. All right, and then we'll pass this guy the decimal. Okay. In fact, actually, with that in mind, do we even need a converter class?
No. I
Those
was
are-
really curious as to why you were doing
Those are pretty straightforward.
It's literally just.
Well, no, we still might need a converter class because as we store stuff in the register, obviously we're going down the line here of saying, okay, we're going to be able to do math with these, right? So we're going to need to pull it out of that string format back into something else. So I guess we could use integer.parseInt to do it. So we can just always store the stuff in hex.
And then always convert it.
Convert it to an integer, do your math, convert it back to hex.
Yeah. All right, so we're making the assumption that we always store in hex regardless of how they enter it in. They might enter it in decimal, binary, or hexadecimal.
That's what the emulator does.
Yeah, exactly. Okay. All right, fair enough. So we'll kill this until we create it again in a few minutes and realize why we need it. All right, so right now, this guy works for, I can just type in any instruction and what? It just reads it in and does what with it?
Nothing. Prints it out.
Reads it in and prints it out in the label?
Yeah.
Output text view? Okay, so let me just run this real quick. And right now we need to be able to support we're going to support just the move command. So we really need to be able to handle the parsing of commands, right? So that's one job we need. So, how do we parse commands?
Split.
Okay, we can do a split. And we're looking at bucket 0 to find out what.
You really want to be fancy, you can do regular expressions.
Oh, you could. If we do a split, we'll have a bunch of strings based on spaces, or if we do comma delimited or something like that, that's fine.
Basically, like 2 times, like with the space, the first component will be a command, and
Yeah.
the rest will be
But what we're really interested in initially is what command, right?
the
Yeah.
rest.
So right now we only
there's
support
always-
move.
There's always a command followed by a space, so you split in the space, and there's always going to be.
What if there's 10 spaces?
Well, then you can concatenate everything after bucket
Okay.
1.
So let's, here, I'm just going to type in something here. Move AX, comma, 15. Emulated, so that's just spitting out that we read that in. Okay, so we want to start off by taking this string and we want to parse the command, right? So we're gonna parse the command. And what we want to know is what command was issued here. So we want to ultimately know that we entered in move. And then from there, we know that move then indicates that we need two parameters. Okay, the destination, which is either, well, in our world right now, it's just a register, but in the 8086 world, it's a register or a variable memory location. And then the source, which is register, memory location, or immediate. In our world right now, just immediates, right? We're moving value into register.
Probably weren't supposed to do register to register.
You can. I mean it's not, doesn't make it any harder.
Well, you just have to evaluate expression.
How did I assign it? I assigned for both?
But you just said the move command, so I assumed that you wanted.
That's fine. However you did it, as long as it does roughly what move is supposed to do, it's reasonable enough. Okay, so let's go ahead and parse the command. So if I read something in like this, with the understanding that I could have a whole bunch of spaces in here, and there could also be spaces in between those guys. You're kind of at the mercy of what the person types in, but the generalistic syntax for the 8086 instruction set is always command, followed by white space, followed by destination, followed by white space, followed by comma, followed by white space, followed by source. And then there's a couple of commands that actually take three things, but in terms of our simple ones, they're all like that. All right, where white space is 0 or more spaces. In our world, it could technically be carriage returns and stuff like that as well. But all right, so we're gonna write a little function called Parse Command. So we'll do that down here. So here's our emulate button press. So this gets us our text. Let's go ahead and store this guy in a string. So we'll say string, let's call this guy entry is equal to this guy. And does that give us a string, or does that give us like a to get?
You have to do get text dot to string. That's it.
Yeah, it gives me an editable. Yep. All right, so that'll put that into a string for us. And now we want to split that string up. So we're going to say string array parts is equal to entry dot split. And actually, we could split this on a regular expression here. Isn't there a... Nah, we'll just do this. I really don't want to do it on...
Well, if you have a space, and then couldn't you just parse or split it up off of the first space and then the comma and index of the comma plus?
I think to give us the most flexibility here, it would probably be in our best interest to loop through and literally follow the pattern I just said. We could use regular expressions to do that.
You want the reg here? Put it in the slide.
Oh, the regular expression for this?
Yeah.
All right.
It'll remove the
white space.
yeah, and return it to 1. So if you have like multiple white space, it'll just put it to 1.
You can trim it.
Well, that trim just takes it off the end, not in the middle.
So if there's 10 spaces in the middle between the hey, look, something actually involved in class.
Oh, that's weird.
I don't know how the replacement works exactly.
All right. Yeah, that's our regular expression, so that should do it.
you want to do replace all.
Okay. What's it complaining about here?
Oh, you got an escape character. Okay.
Oh, this guy. Well, no, that's not part of the
You
regular.
just need the double escape characters. So
Oh, you want this?
yeah, but now I have no idea what it is.
Well, this is what used to be there. That was the old command. And if I escape it this way, it says anything followed by one or more spaces.
/ is an escape character. So
Okay. Well, the escape character. Are you talking about the escape character in a regular expression or escape character in Java?
the string. I'm trying to figure out what the string. Which characters the string is complaining about.
Well, it's
Expression, replace spaces with single space.
That's JavaScript.
That's fine.
Yeah, that's the exact same thing that I was looking at. So
Okay, so this is their regular expression.
does it not have to be a string? Because you
Well, \s is spaces. So this guy's saying we could just do a single space there. Let's look at just Java. So this is one or more spaces with a single space. So it's using a pretty weird regular expression format, but it's fine. But this actually doesn't even solve the real problem. This guarantees us a single space before the.
yeah.
So let's. I think we're trying to just be too fancy here. Let's just write this.
I just took the first 3 characters and whatever you put in.
3 characters should actually be okay because I think 8086 every command is.
There's 2 characters and there's 4 characters.
Oh
so
yeah,
split it
push
up.
and pop.
But right now
push.
we're only using
Right.
3 characters. So just call the first
so
3
what?
letters.
Why don't you
characters command?
take the substring until the first space?
Yep.
And that's your instruction.
That's your instruction. Yep.
Then from there to the comma is your destination.
There to the next non-space.
Well, comma.
No, next to the next non-space because you're going to have something that looks like this. Move AX, comma, BX, something like that. So everything up to the space is my command.
That's your command.
Then everything from here up until the comma
Yes.
is.
So you go from the space.
So that
to the
trimmed.
comma, yeah.
That trimmed.
That trimmed, and then you do the comma forward. Well, without the comma, but
Yeah, I gotcha.
or with whatever you can do a space after the comma too.
Okay.
So what I did was,
So we know that'll be parts.
so you split it up into 3 parts, because that's all we know about right now.
And I mean, you could always, with this.
So I did this, the input, so mine was input, yours is entry, that substring of 0, and the input of index of the first space. And then from there, I did the index of that space plus 1 to the comma. And then from there, I went from the comma plus 2 to the end. because it gives you the comma. Then I did the space after the comma.
To
Well,
a certain extent, you could make
Or
it.
you could just do the index of that dot and then trim it.
I'm gonna do something here.
You
So-
could always just make it a in order to be able to function correctly with all of the other commands. You could always just parse enough to get the instruction, and then specifically parse it out how you know the commands are parsed out for each different command within their own.
I still think we're just making this more complex than it needs to be.
Well,
We can just walk through this and build up strings and put them inside of it.
That's what I did. I just did instruction is the substring from 0 to this first space. And then from there I did for the destination is the substring from the space plus 1 to the comma. And then from there, the third one was just God.
So this is what we're doing. So starting off is get command. All right, so I'm just going to have a function here called get parts. We're going to take in our entire string that was entered in, and we're going to walk through this guy. And we're going to put the first element of this linked list is going to be our command. But we have to build up that command first. So string command starts off as the empty string, and then we'll say while. And let's create an integer here. Pause. Start this off at 0. So while entry dot charat pause is not equal to a space, command plus equal entry dot charat pause pause plus plus. All right, so this is going to build up inside of command every character starting at the beginning of entry, and here we could even say something like just so we don't have an issue, entry is equal to entry dot trim, just to make sure we don't have extra spaces on the front or something like that. So this is going to go through starting at pause is 0, and we're going to keep concatenating onto command every character that we find until we finally bump into something that is a space. And once we have something that is a space, we know that command holds our actual command.
Then why would you loop that?
I'm walking one character at a time.
But why?
Why not?
Why wouldn't you just
MOV.
Why wouldn't you just use the substring from the
You could. You certainly could. That's effectively going to do the same thing.
Okay.
But I think this is going to be pretty clear how we're going to grab stuff, because we can specifically say walk past white space until we hit this, and then keep going until we hit comma, then keep going.
Okay.
I mean, we're only grabbing a couple of pieces.
Yeah.
So since the structure isn't completely consistent throughout, I don't think that using some of these other things, I don't think it saves us any time.
Okay.
So once we're done with this, and here, let's do linked list of string. Call this guy answer as a new linked list of string. Okay, and so now we have our command, so we'll go ahead and say answer dot add last command. So we'll add that to the end of our linked list. Okay, and we could certainly, if we wanted to go more of an object-oriented route, we could certainly have a command object that has the command type and then the parameters or something like that, but I think this will be good enough for what we're trying to do here. Plus it feels more low level, so it'll be similar to what we're actually accomplishing. All right, so now we have our command. After we have our command, what do we want to do? We want to burn past white space. We're currently sitting at position pause in our string, so if we give ourselves our little example up here, move AX comma BX, something like that. I'm sitting right here. All right, I want to burn past white space until I finally hit something that's not white space.
Replace all your spaces within that space. And then just make them empty.
So, well, I could take the substring from that point and then replace empty spaces, but I still say let's just write a while loop that just walks past spaces. Like, I don't think we need to be horribly fancy about, computers are fast. So can't we just say this? Skip white space. So while entry.char@pause is equal to a space, pause plus plus. So when I'm done with this, I know I'm sitting on the beginning of my first parameter, my destination register, right? So we're going to read dest. So string dest is equal to the empty string while entry.char@pause is not equal to a space. Dest plus equals entry.char@pause pause plus plus. So when we're done with that, dest will hold our destination value.
Wouldn't it be comma?
And
Yes.
Yeah, because we're sitting, where are we at?
We're in the destination.
Right. So we've already burned past this. So this was my burn past things here. Now I'm saying as long as pause is not a comma, you're right. So as long as this guy is not the char comma, put it onto dest, and then we'll say answer dot add last dest. Okay. Now some commands have some commands will stop with just one element, right? For instance, increment, the increment command. When we increment, it's just boom, and then the destination register. There's no second or third parameter to that guy. So what we're going to do here is this is really an optional part. In our move, it's going to definitely be there. We'll definitely have at least one extra parameter for move. Well, exactly one extra parameter for move. So if I'm currently sitting right here, I'm looking at the comma, I want to burn past that, right? I know I'm staring at a comma. So move past comma, that's just pause plus plus. That'll move me past that comma. So now I'm sitting right here. And then I want to burn past white space until I either hit something that's not white space or I'm off the end of the string. Okay, so I know that I'm going to process stuff from where I am right now all the way to the end of the string. Actually, we have a bug here because it's not just comma. It could also be, it's an illegal position, because if I had something like this, inc AX, there would be no comma. So I need, because I've trimmed it, I know if it's the end, that this is going to be the end of the string. All right, so I really need to have, if I'm going to make this catch-all to support the various commands, I'm not just going to comma, I'm going to say while pause is not equal to entry dot length. So as long as we're not currently off the end of the string, and the thing we're currently looking at is not a comma, keep collecting stuff. All right, and then we'll have our destination. So now when I'm sitting here, we're either at the end of the string, so if, well, I don't need to put a comma there. So if pause is equal to entry.length, so that says if we're currently sitting at the end of the string, we're done, right? We've read everything in. So we can go ahead and return answer.
Are you going to worry about pointers at all at this point?
Not right now. I mean, I don't, what pointer?
So if you're moving something to a specific pointer?
Oh, to a memory address specifically? No, right now we're keeping it relatively simple. We'll have to, I mean, this is effectively our parser for our language, right?
Yeah.
I mean, you know, it's not going to be overly large, but we'll have to add some things to it as we go. But I think this will allow us to get the individual pieces pretty easily, because 8086 assembly is not all that complex. Well, even modern Intel architecture assembly is not that complex from a language perspective. Everything else, I mean, so the complexity is moved out of the language and is put into the programmer, right? because we have to feed it the 4 million lines of code in order for it to accomplish something. All right, so if I'm at the end of the string, then I'm done. Return my answer. Otherwise, burn past comma. So that'll be my pause plus plus. All right, now I'm going to have one or more parameters, right? If I'm sitting here after the comma,
There's commands that don't take any parameters.
So that's when it returns.
Right? It was
everything takes at least one.
Not according to this documentation.
Trying to think.
Like the CLI clears the arrow to enable flag.
Oh,
So that means we just check it beforehand.
We just have another check.
yeah, it'll be this guy.
You don't really need the else, right? Because it'll just continue otherwise.
Correct, yep. So this is where we're getting our command. So if pause is equal to entry.length, return answer. We can say, was this a command with no params? Something like that. Then we'll skip past white space. Then we'll read our destination. And then was this a command with a single param? Like that. And like you said, the else is optional. It's not wrong, but it's optional.
But don't
So-
you pass substring to the next comma and go past it, because technically there could be filler in between.
Well, there wouldn't have been filler in between because I get what you're saying.
Because yeah,
It could be that.
yeah.
Yeah, we could have a space or a comma. Could be our stopping point here, right? So as I'm coming off the end of this guy, I want to keep reading stuff until it's either a space, a comma, or the end of the string. All right. So while we're not at the end of the string, and it's not a comma, and entry.charat pause is not equal to a space. While all three of those things are true, do that. If we are at the end of the string, we're done. Otherwise, we're going to burn past white space, which may or may not be there. So that's, here's just skip white space. We'll just steal this guy. So that's getting past our optional white space. Then we'll burn past the comma, and then we're ready to read in. So now,
Skip white space, right?
yeah, I did that first. So burn white space, burn past comma. So now I'm sitting here. Now burn past white space again, right? Now, something we want to see here is that this pattern, actually it's really this pattern. That pattern right there of skip white space, skip comma, skip white space, read param is the process of reading in our next parameter. And we want to keep doing that until until pause is off the end of our string. That make sense? So really, this stuff right here, we're going to say while pause. Oh, and actually we can incorporate this into this piece up here. So we can say while pause is not equal to entry.length. While we're not off the end of the string, do stuff. And then after we're done doing stuff, we're going to return whatever the current version of answer is. So what are we going to do? We're going to skip white space, then skip the comma, then skip white space again. Read param. Okay, and read param is going to be the same thing as we did up here. effectively this guy. So start param off at the empty string as long as pause is not off the end. Entry is not equal to a comma, and it's not equal to a space. Go ahead and read into param. Next value of entry at char at pause, increment pause, and then we'll add to our answer the param we just built up. Now we're currently sitting either at the end of the string, off the end of the string, or we're sitting at a space, or we're sitting at a comma. Right? We just read in. So burn past white space, burn past comma, burn past white space, then read in param until I hit end of string, space, or a comma. All right, so after I have this guy, we went ahead and added it, and now I'm either sitting off the end of the string, or I have space, or I have a comma. Go ahead.
Why don't we put some kind of semicolon at the end as a mandatory, as this is our classroom?
Well, we certainly could, but that's not what 8086 does. So since we're mimicking the 8086 syntax, that's not what they do.
Still, as per our instruction processing, why don't we use any character at the end of the instruction? If it is increment, move, anything.
We certainly can, and it might even make life easier, but that's not what 8086 did. So we're literally mimicking the 8086 instruction set.
Doesn't it technically use new line to terminate?
I don't think modern emulators would. I'm not positive on that. Because that seems to be dangerous right off the bat, because new line is different on different architectures. But given its vintage, it probably does use new line. Just because of how old it is. But knowing what we know now, that's probably not a smart way of going about it. And technically, we are using new line as well. We're using end of string, which effectively means they pressed enter. And, so I guess we kind of have the same thing here. All right, so after we have our first parameter, so this is the special case guy, right? If we have a first parameter, he's the guy that doesn't have a comma before him. Otherwise, we burn white space, burn comma, burn white space, then read in value. So right here, as long as we're not off the end of the string, burn white space, burn comma, burn white space, read in the parameter, which means we're going to keep reading stuff in until we're off the end of the string. So while we're not off the end of the string, and we're not a comma, and we're not a space, keep building up param. When we finally fall out of this while loop, we know that param has our parameter in it. And one of two things is true. We either are at the end of the loop, which means that we are at the end of the string, which means that this loop will die the next time we loop back up, or we're looking at white space, or we're looking at a comma. That make sense? So we'll add our param. Then we loop back up. Is pause not equal to the end of the string? Are we off the end of the string? If we're not, skip the white space, skip the comma, skip the white space, read our next parameter. Over and over and over again. So it should get us as many parameters as we have until we finally run out of parameters. Make sense? And we should be guaranteed not to have extraneous white space at the end of our command. We should be guaranteed not to have that because we did a trim when we started. So we won't have to worry about, oh, I didn't get everything or something like that. Okay, and then finally, we'll return our answer. Make sense? All right, so now to test to see if this guy does what he's supposed to do, let's go ahead and we'll call get parts on the thing that was passed in. So here's our emulate button. And we'll say linked list of string called parts is equal to this dot get parts, and we'll pass it our entry. And then let's go ahead and just build a string out of our parts, but we'll put you know, some dashes in between it so we can kind of see where they're separated, just so we can use our same output thing here. So we'll say string output. I'm just going to say string out because it took me 3 tries to not spell it right, so that's where we're going to say for s in parts, and we'll go ahead and say out plus equals, let's do s concatenated with space dash space. We'll have just an extra dash at the end, but this will at least show us that we have the right stuff. Take our output guy here.
Doesn't like that you have to put the string in it first.
Yeah, it's string s. And then we'll go ahead and we're going to output out. All right, so we'll read our crap in. We'll have our get parts parser go ahead and piece it into its individual pieces, which is going to give us a linked list of all the individual parts. And we know the very first element in that linked list is the actual command, which should tell us what else we'll find in the linked list. Then we'll build a string just for output perspective, because we only have a single text box right now for showing stuff. We'll spin through all of our parts and just build a string with some dashes in it so it shows us where it delimited that stuff. And then we'll ultimately put that in our output. So let's test this with a couple of commands. All right, so we'll do move. I'll put some spaces in here. AX, comma, 14. I'll put a couple of spaces after that. Emulate, there's move, there's AX, there's 14. Seem to piece those pieces out okay. And let's just do it with move AX, comma, 14. So we don't have anything. Well, here, let's do 17 just so we know what changed. So there's move AX 17. All right, so we ran 2 tests. Let's just assume we exhaustively tested this. And code must be perfect, right?
Yeah.
Yeah, I've never introduced bugs into my code, so this seems to make sense.
It's not possible.
That's just not
The
possible.
keyboard just doesn't let it happen.
Bug-proof keyboard. All right.
Make a typo, it shocks you.
Okay, so we have this guy. Now, let's go ahead and let's implement his version of our registers, because I think that's a pretty good approach, at least for mimicking the 8086 dealie. So we have our, what's this?
But mine's faster.
It might be, probably is. Well, it definitely is, because this is doing all string manipulation. Although his could just do chars. Yeah. They're both adequate, so there's nothing wrong with either of them. Let's see, do we want to do a register object where a register has a high and low? Maybe not, because not all registers are.
Well, all the ones of the same size will.
I guess that's true. We can have an object called general purpose register, and that guy has a name.
Well, all registers break down into
What
8
would you need
button
the name
bits, right?
Huh?
The name?
Yeah, when we look it up. If I say I want to move something into AX, I need to go and find that destination.
Yeah.
because we're also then going to have a variable environment for memory storage.
You could have a dictionary of registers. You have a diction, and one of the dictionary, and one of the you have an A, and that points to either an array or a linked list or some section of memory or something, and then you can just call that dictionary as bucket A or bucket B or whatever.
Yeah, it might be best to call these guys storage, because storage comes in the form of various kinds of registers and a value and a variable. So we have, when we say AH, if I say move 13 into AH, I need to be able to locate AH from that.
AH is just an arbitrary name given to a 8-bit.
Well, it's an 8-bit half of AX.
Well,
Right, but it's still an arbitrary.
So if you say
label.
AH and you had the register of the 16-bit object of a 16-bit register, could you just do high and low, and then it would just automatically, if you typed in AH, it automatically put it in the high?
Can you have AH be 8 bits ever? Or, I mean 16, so it's like a.
Not in 8086.
Okay.
In more recent, yeah, more recent architectures, it would be. I'm just thinking, kind of looking forward, how we can make this flexible for other architectures. If we had a list of storage, like a JSON thing of storage for our various registers, we can say name of register is AX 16 bits, BX 16 bits, and then I guess we could also then have high and low of that, where high would be half of it and low would be half of the 16. So if AX was a 32-bit register, then high would be 16 bits and low would be 16 bits. Not that we're necessarily going to implement that, just thinking about it from a, kind of picking the right way of doing this to begin with. If we make it too generic, then we run the risk of a register that doesn't have a high and low allowing a high and low.
Such as?
Well, like SP is a register that doesn't, it's not one of our general purpose registers, which is kind of why general purpose, all the general purpose have high and lows.
So, the thing is, SP, it doesn't have a high and low. But if we use the register in high and low just as the first 8, don't think of it as separate registers, except for the general purpose ones, then we can do it that way.
Yeah, so I think the object-oriented version of this, though, would be to create a general purpose register object.
Yeah, you would have.
And it takes in a size. It takes in a name and it takes in a size. And since it's general purpose, it automatically internally defines a high and low.
That's probably the best way to do it. I don't know about the best way, but you could have, the way I was thinking is you could have an abstract class, which is the bare minimum, which just holds the register size. And then you have the general purpose class, which inherits from the.
Yeah.
Whatever.
Well, hold the and the name. It'll hold the size and the name would be the abstract class.
Right. Yeah.
Okay.
So something that you can get it, and then once you get it out, you can see, oh yeah, this is general purpose, so now we can use it as general purpose.
Yeah, because
High
all
level.
registers, regardless of their type,
Mhm.
are going to have a name and a size.
Yep.
And actually, we can take it beyond that. It's not all registers; it's all storage locations. Because even when we get into variables are still have a size. It's a double byte or a double word or quad word. Actually, quad words don't exist in 8086, but the point is they all have sizes as well. So you want to create. Let's do we'll do an abstract class here called maybe just called storage. Fair enough. So that guy's going to be abstract. Okay, and we're going to say that storage, they all have, we'll do protected string name, and then protected, close enough, protected int size, something like that. So they'll all have those two elements, and if we need to come back and add some stuff, we can. So then, from here, we're going to create a general purpose register, which has a name, which has a size, and then has general purpose register stuff like high and low and those guys. So we'll create another class here. And this guy extends storage. And then we'll have our constructor for this guy, public general purpose register, and this guy will take in a string name and an int size. Say this dot name is equal to name, this dot size is equal to size.
Let's do base. Can you just do this?
Yeah.
Okay.
You said you thought you did base?
Is that not a thing in Java?
I've never heard of it. Yeah.
In C# you can just essentially in the constructor after.
Yeah, it's the base class.
Yeah, you could, well, after the public whatever, you could just do that storage could have its own constructor, and you could just do :base, and then you pass the name size, and then.
Oh, I got you. It's a section. It's a section for all the base stuff.
Yeah.
I get it. Okay, so yeah, this dot name is name. This dot size is equal to size, and then we're gonna have because this guy has a high and a low, we're gonna say so his name would be AX. Well, do we want to name the high and low here? I think we do.
Don't you want to give a type to storage as well? Like what type of storage it is?
Well, this is general purpose.
Right. So within the abstract class storage, don't you want to give it a type? Say this is general purpose versus this is, so you can type it easily, or do you just want to?
I don't know that we have to type it since the classes are going to type it themselves. And we could decide to go back and throw that in, but at least right now. So why don't we do this?
What distinguishes it from a regular from a 16-bit versus the 16-bit general
Size.
purpose? Size.
This is, this is our general purpose object.
But what he's saying is, you know how you said that if it doesn't have a high and low, what says?
All general purpose registers do.
Right.
Yeah, so we'll have a different object for the ones that don't have high and lows. All right, so what we'll do here is, since this is a general purpose, it's going to have the actual register's name, the actual register's full size, and then string high name, string low name. Okay, and these guys will take in a private string high name, private string low name.
What was that?
Maybe one key off on the keyboard. This dot high name. Yeah, see, we're having problems here. High name. This dot low name is equal to low name, and then we want to have high size and low size. Actually, maybe we do offsets. Private int.
Do you really need a high size and low size if you have a size?
We can calculate it.
Half,
Yeah, we can calculate it. Or if we decide we need it, we can always add it later.
Yeah. But you can probably just put some public setters in there as well after the fact.
Right. Okay, so these guys are our general purpose registers. They have a name, they have a size, and they have a high and low name for those sub registers for for half of it. All right, so now a general purpose register also is going to have a value, string value, because we're going to hold the values in hex, right? So we're going to store those as strings. Although, let's think about this.
Regardless, anyways.
It won't be a string. It's going to be every general purpose register would have 4 buckets in it, right? The size of those buckets is what might change. So if it was a 32-bit register where we had 16-bit halves,
So
we need to be able to store the hexadecimal value. So an 8-bit half is 2 hexadecimal digits, right? A 16-bit half would be 4 hexadecimal digits. Digits, not the right word. Hexits? Hexits?
Values. Just say values.
Yeah, but I wonder what the real word is. A digit is an individual number of the base 10 number system. And is an octet would be the octal number system? Hexit? Hexit? Hextet? Digit? Hexit? I think it's hexit.
Hexadecimal. Hexadecimal number.
Oh, that's just a cop-out.
It is.
They just kind of gave up. Okay.
Hexadecimal value, number, hex.
All right, so this guy's actually going to be a... Is it always going to be 4? 4 halves. So every 4 bits is a hex value, right? Okay. So this guy is going to be a string array called, actually it's going to be a char array. Called value. And then we're going to say this dot value dot is equal to a new char array of size, this dot size divided by 4. That's the number of hexadecimal. That's the number of hexits that we need. that we need.
There's an octet, which is the 8. There's the nibble, which is the
4, yeah.
Doesn't say anything about hexit.
All right, well, it's a hexit. That's what it is. It's a hexit. So we have 1 hexit per 4 bits, right? 1 hexit per nibble. So I divide the total number of bits divided by 4. That's the number of hexits we need. So that's the number of chars that we need to represent the value for this general purpose register. Make sense? And at this point, this is just a storage container for that value. We haven't actually put a value in there yet. Okay, so that's our constructor for our general purpose register. Now we need to be able to load a value into that. So we need to be able to load high, load low, and load. Those are the 3 functions.
Well, why would you need to load low, load high?
If I'm moving something into AH, I'm going to be putting it into the high portion of the general purpose AX register. Or maybe,
Doesn't it go to low first?
huh?
Or
It goes low first.
Well, it goes wherever I tell it to go.
wouldn't you create your own register though?
Create your own register.
So wouldn't you create another register and have a pointer to that? If you're going to do it completely object oriented.
No, because I get what you're saying.
So you create
This guy, instead of having a char array representing its entire division, it would have 2 general purpose registers that are smaller in size. The problem with that, though, is that the AH and AL aren't subdivided. So they don't have a high and low. We don't have an AHH and an ALL, or yeah. So we would have to, if we want to make it completely object oriented, we would have to have another. It wouldn't be called a general purpose register. It would be a
16-bit register.
It would be a sub-register or something like that, which has a name and a size, which is okay. I mean, there's nothing wrong with doing that, but it might be overkill. Plus this, I think, maybe lets us think about it in terms of if we're comparing it to EMU 8086. All right, so hextet.
Hextet.
Did I say that? Was that one of my options? I said a lot of different things.
Hex, T-E-T.
I think you did IT.
IT, hexet.
Hextet.
I might have just mispronounced it.
Maybe Hextet. Hextet?
All right, so let's just get this load working, and then we'll take a break. What's wrong?
You're just gonna go.
I go to the bathroom, but I mean, I can wait.
Oh. So it'll give me 2 minutes. I think it'll only be 2 minutes because that'll be a good stopping point. So we're going to do a load high, load low, and load. So public load is going to take in a. We can have this guy take in. Do we want it to take in a decimal value and integer and then do the conversions in here?
But
That'd be easiest, I think.
That
You're taking a
implies that
string,
you're
and then
always
you-
passing a decimal.
You said you can take in whatever value. You can take in a hex, decimal,
Well,
octals, whatever.
so
you
in
want
that-
to take in a string, figure out what type
Well, I
it is,
mean-
then parse it.
Yeah.
Well, I mean, so what you would do is you'd have multiple different load functions for if it was a string or if it was a.
Well, you can have one load function and figure out what it was.
Yeah.
So you're saying take in a string for this. If it has no, because 8086 says if it's an H on the end of it, it's a hex. If it's a B on the end of it, it's a binary. Otherwise, it's a decimal.
On the
Octal's an O, right?
if it's hex, the first decimal, the first character has to be a 0.
0x.
I don't think. I don't.
Not an X, just a 0.
I don't. No,
When I tried it out,
that doesn't make sense.
Really?
That
Because
literally
it
doesn't
would
make
have
sense.
hex. What if you're putting in just an A? Then it's AH that's looking at the register. You have to put a 0 in front so it knows that it's.
Yeah, but
Oh.
then you put the H at the bottom so that you know that it is.
No. I think he's right.
There's no.
Yeah, I tried it out
It's
on
on
the
0x though. Like
No, it's not. It's
No, that's
just
a
0.
display format for
It's
hex.
just
Is 0x.
0 and then.
Right. I've always
the
seen hex
value.
numbers represented as 0x, like FFF.
But that's a display format for it. If we outputted a memory address, outputted a hex value, that's how it would display itself.
Right.
This is just 8086 choosing what it accepts as input.
Right. So is it?
There's no X. It's just a 0,
Yeah.
the hex value, and then an H to say that it's a hex value.
But that 0 only makes sense if there's an H. Those two need to be present.
Yes.
Okay. Did you get the same thing? Do you have the new OS on yours?
So I get that.
All right, let's take 10 minutes and we'll come back because I think we want to debate and make sure we get this right.